I did. I signed
One half.
Okay, someone had a question on homework?
Either number 3 or number 9. Probably number 9 would be better.
Number 9 or number 3? You said number 9?
Yeah.
Okay. Was that?
3, just kidding. 3 works.
Okay, this is from section 7.3. Homework problem number 3. And can someone tell me what's the integrand?
Radical 5 plus 4x minus x squared dx.
5 plus 4x minus x squared. Well, if you have done number 9 and number 3 are actually exactly the same. The same ideas goes into both of them. The first thing you need to do is that you have a quadratic inside the root, and what you need to do first is you have to complete the square. So that's like the first week of freshman Calc 1, right? Where you learn how to do that, or you must have learned it when you were in high school as well. So I start with the quadratic that I have, 5 plus 4x minus 5 plus 4x minus x squared, and I am going to write down the square first. 4x plus 5, and I am going to factor out a negative from the first two terms and rewrite that as x squared minus 4x. So my goal would be to complete the square. In order to do that, in the parenthesis, I am going to write down x squared minus 4x again, but then I am going to add a number so that I can complete the square. Now, what I need to do is look at the coefficient of x, and coefficient of x is 4. Take half of that, which is 2, and then take the square of that. So 2 squared is 4 again. So I'm going to add a 4, But because I didn't have a 4, I have to subtract that 4 as well. And of course 5 is still there. Everybody is okay with that? Take the coefficient of x, take half of that, and then square it. That's 4. That's what I'm writing here, and then minus 4, because 4 was not there. The reason for doing that is that if you look at the first 3 terms, can you FOIL it? You factor out, what do you get? X minus 2 times x minus 2, right? So what is that? That's x minus 2 squared, and then minus a 4. And then I will distribute the negative. So I will get negative x minus 2 squared plus a 4 plus a 5. And then, so finally what do I have? I have 5 plus 4x minus x squared. That's equal to 9 minus x minus 2 squared. So that's what we mean by completing the square. So my integrand now, my integral now looks like the following, right? My integrand was this, right? So I can replace that with 9 minus x minus 2 square, and we also had a square root in the integrand, and dx. So now it looks like 9 minus x squared, right? It looks like 9 minus x squared. So what's my guideline for 9 minus x squared? I am going to do what substitution? Yeah, so what should I replace with sign? Okay, x minus 2 will be 3 sine theta, very good. And remember, theta is where? Theta is, when we make this substitution, we have to make sure theta is in the, between negative pi over 2 and positive pi over 2, in the first or the fourth quadrant. And I'm not going to write that down. So this is x equals to, oh, I don't really need that. So what is, if I take, what is dx? 3 times, the derivative of 2 is just 0, so you just get dx. And then this is 3 times cosine theta d theta. Now my integral then is 9 minus 3 sine theta squared, and then dx is 3 cosine theta d theta. Let me close that door for a second. Okay, so I need to remember the whole goal for substituting trig functions is that we want to get rid of the square root. So here I can say that I have 9 minus 9 sine squared of theta, and then here I have 3 times cosine theta d theta, and I can factor out a 9. We get 1 minus sine squared. If you can skip some of these steps in your solution, that'll be okay. But just make sure that you don't make a mistake, though. And what is 1 minus sine squared? Cosine squared. and the square root of 9 cosine squared, well, that's just 3 times cosine, right? And technically speaking, I should have written absolute value of cosine, but we know that cosine is positive for the values of theta in the first and third quadrant. So 3 and 3 would be a 9. So this is cosine squared theta d theta. And what do we do with even powers? Even powers of cosine? Very good. 1/2 1 plus cosine 2 theta. And take the half outside, you get 9/2. So you have 1 plus cosine 2 theta. And this is 9/2. What's the integral of 1? Theta. What's the integral of cosine 2 theta? One half sine 2 theta. Everybody realizes where that half comes from. Okay, so let me show you where that is coming from. So you're taking the integral of cosine of 2 theta, right? And if I only had theta, this is sine theta, right? So I should do a substitution like u is 2 theta, and that substitution will give me what? Will give me cosine of u, and what is du? Du is 2 d theta, right? But then d theta is half du. So you get a half du when you make that substitution, and then that half will go out of the integral. You get cosine of u du, right? And then that's cosine of 2 theta. Sine of 2 theta. Okay. So let me just complete. This would be half sine of u, and then this would be half sine. Because I have to go back to theta, I get half sine 2 theta. Okay. All right. So now I am done with the integration, but this was indefinite integral. Therefore, I have to go and replace a theta by x again, right? So how do I do that? Well, what was the substitution we did? We did the substitution. We did the substitution. X minus 2 is 3 sine theta, right? So from there I could say sine theta is what? X minus 2 divided by 3. So sine is, we know sine is what? Opposite over the hypotenuse. I'm not going to make a circle or anything, I'm going to make just a right triangle. And let's say theta is this angle here, then the opposite, I can take the opposite to be what? X minus 2. The hypotenuse would be 3. What is the adjacent then? The square of the hypotenuse minus the square of the opposite, and then square root of that. Notice that this is exactly what? This is exactly the original 5 minus or plus 4x minus x squared. Okay, if you expand it out, you'll get the same thing as the integrand you started with. And so what is well, now I need to know what. Remember, my result was 9/2 9/2. I'm coming from the integral, right? So this was the value of my integral. And I had 9/2 times theta plus half sine 2 theta, right? And before I can write this in terms of x, sine 2 theta, I have to write it in terms of just theta. So you have to apply another trig identity, which is 2 sine theta cosine theta plus the c. Yeah.
You said that was the double angle rule.
Say it again.
You said that was like the double angle rule in one of your examples.
This is the double angle. So sine 2 theta is the same as 2 sine theta cosine theta. That's the double angle formula for sine. And
Have we proved that before?
well, I didn't go over trigonometry in this class, right? I didn't show you any of this. I didn't review any trig. Is that what you're asking? No, I didn't prove this identity for you.
Okay, so
Yeah.
should we just memorize that? Or should
You should memorize that. I mean, you are expected to know this from your trig class and Calc 1.
does that work for other forms of trig as well, just to memorize?
This formula that I have here, you're going to use it in Calc 3. You're going to use it in differential equations as well.
Like if you had 1/2 cosine 2 theta.
Cosine 2 theta formula is a little bit different. Cosine 2 theta is cosine squared minus sine squared, or you can write it as cosine 2 theta can also be written as cosine squared minus sine squared. So cosine 2 theta is cosine squared minus sine squared of theta. And you can also rewrite this by, for example, if you can write it as 1 minus 2 sine squared of theta. You can also write it as 1 plus, you can also write it as 2 cosine squared of theta minus 1. Okay, so cosine 2 theta formula is different. So there are three ways you can write cosine 2 theta. Yes, that's why math is not forgiving. Okay, so if you didn't do your job in high school, you are penalized when you come to college. If you don't learn your Calc 1, you are penalized in Calc 2, and so on. So whatever you didn't learn, even probably going back to your grade school, right? If you didn't learn polynomial division, right? So you will be punished later. So the math is not forgiving at all. Okay, so I'm pretty sure you realize that if you didn't work hard in physics or chemistry in high school, I'm pretty sure you can still do a good job in college if you work hard. But math, I think it's not going to happen. Okay. So, but it can happen if you actually make the effort and give up watching TV, give up your social life, and just do your work. Then probably you can make up for that. Okay.
Yes.
So. All right. So let me finish this off here. Then 9/2 theta sine theta cosine theta plus a c. And what can I replace theta with? Remember, we had sine theta is x minus 2 over 3. So theta would be what? Yep, very good. X minus 2 over 3. And then sine theta from our triangle, it will be opposite over the hypotenuse. So x minus 2 over 3. Well, that's what we picked. So this is x minus 2 over 3. And what is cosine? Cosine would be the adjacent over the hypotenuse. So the adjacent was 5 plus 4x minus x squared.
Is that okay if we kept it in?
Yeah, that would be fine as well. Yep, plus the c. And I'm not going to bother to simplify it anymore, but you can see 3 times 3 would be a 9 and so on. So I'll just leave it as it is. Okay, any questions, anyone? Yeah. Questions, anybody?
What is this used for in work?
What's that?
What is this used for at work?
What is the what?
What will we be using this for in the future?
What you're gonna use you're going to use most is that the fact that you can carry out you can think through complicated computations, and that's the skill that wherever you go, you will be expected to be able to reason through whatever new problems you see. So that was that.
Making us tough.
It's making you tough, yes. And of course, I mean, most of you will not be working probably anything where you have to really be using it directly. But one of the things is that a lot of this, for example, are used in DFQ, and differential equations is basically is really applied mathematics. That is, differential equations are used to model real-life problems in engineering or in many other places. And so if you are using differential equations as models, then these are the things that you need to know. Okay. But I realize that many of you will not be going into any jobs where you have to use it directly. Okay. But one of the reasons, I guess, like I said, these things do appear in DFQ again, and again, the thing that you want to utilize here is that can you think through problems on your own? Okay. It doesn't have to be just math. I mean, whatever the problem you face in engineering, for example, your employer expects you to solve problems. Otherwise, they wouldn't be paying you much, right? If you cannot solve problems for them, if you just do the routine type of work, then the salary isn't as good as where you will be responsible for solving problems. Okay, so. You will be expected to solve problems on your own when you go in real life. It might not be a math problem, but still the skill of thinking about something is what is required there too. Any questions at all on any other problems?
Yeah. Question on another problem.
Hey, that's a good one.
So what if I give you this same problem in a little bit different form? Just change the numbers. All right. So I have only 5 minutes or so. What I'm going to do is just show you one more example in 7.4, okay? So 7.4 the last case that I have was case 4, and in case 4 the question is we have a fraction which looks like I thought I brought my I should have it here. Yeah. So let's say I have the fraction 1 minus x plus 2x squared minus x cubed divided by x times x squared plus 1 squared. And okay, so in this problem, the first step is done, right? I don't have to worry about factorizing the denominator. So we go to second step, which is we have to write down the decomposition. And the decomposition in this case would be what? So remember, each factor in the denominator contributes certain terms in the decomposition, right? So what's the contribution of x? A over x, okay. How many terms will be contributed by x squared plus 1 squared? Two of them, because the exponent is 2. So you get a contribution with denominator x squared plus 1. You get another contribution with denominator x squared plus 1 squared. What's the numerator on x squared plus 1? Bx plus c, very good. And what's the other one here? Dx plus e. Notice that, what happened to my numerator?
I can see it. Identify the numbers.
Yeah, I must have clicked something. Okay, so notice that what's the degree of the denominator? Degree of the denominator is what? Of the left hand side? 5, right? Degree of the denominator in the left hand side is 5, because you have x squared, so that's 4, and then another one here, so it's 5. How many parameters a, b, c I have? 5. Okay, now how do I solve it? 1 minus x plus 2x squared minus x cubed. If I multiply out, I get a times what? X squared plus 1 squared plus bx plus c times x squared plus 1. Is that it? Missing an x, plus dx plus e times just x. In this case, the best thing to do would be to multiply out, which is a times x squared plus 1 squared would be x to the 4 plus 2x squared plus 1. Here I would be getting bx plus c times x to the 3 plus x. Here I am getting dx squared plus ex. And finally, I am going to try to come up with what's the largest exponent on the right. The largest exponent I can get is 4. So what's the coefficient of 4? X to the 4. I am going to get a x to the 4 from the first, right here, which I'm going to get a. From these two, I am going to get b, right? So plus a b. And I think that's it for x to the 4. How many ways can I get x cubed? Notice that from this term, I cannot get x cubed. There are no x cubed here. So the only x cubed I can get is cx cubed, right? You guys realize that? Okay, what would be the coefficient of x? That would be the biggest one, I guess. Again, I don't get any x term from the first. What do I get from the second? Say it again. Oh, x squared. Yeah, x squared. I get 2a from the first, right? And then from here I get this. And from the last I get d, x squared. Okay, how about x? The only one that I get is c plus ex, right? And what's the constant? The constant is a. Very good. Okay, so now let's set up the equations. I have the far left side, which is a polynomial here, and I have this guy here. Both polynomials are equal, so the coefficient of x to the 4 on the right should be the same as the coefficient of x to the 4 on the left, and so on. So what should be a? A should be 1, right? A should be 1. What would be C? C should be -1. What would be A plus B? A plus B would be 0. What would be C plus E? C plus E would be -1. And the last one is 2A plus B. 2A plus B plus D. And that's the coefficient of x squared, which would be 2. Alright. Even though it looked pretty bad, but in fact it's not really that bad, because you already know A, you already know C, and from the third one you can say B is what? -1. From this one you could say E is 0. From the last one you could say what is left? What is left? D, right? D would be what? I have 2A, so that will be cancel out. That will cancel out this one. B is -1, so D would be 1. Yes. Okay, so now our fraction that we started with, 1 minus x plus 2x squared minus x cubed over x times x squared plus 1 squared, that's equal to a over x plus bx plus c. Bx plus c. So b is -1 x plus c. C is -1 over x squared plus 1 plus d is 1. E is 0, so I just got x, and then x squared plus 1 squared. Everybody's okay with that so far? Notice that, okay, so far we were lucky with the finding a, b, c, d, but we are not really that lucky in terms of computing the integral. So notice that if I try to integrate this guy, I have to integrate 1 over x, which is easy. I have to integrate this guy, which is not so easy. I have to integrate this guy, which is easy, but you have to do a substitution. It's not a direct one, right? How would you integrate the last term, x over x squared plus 1? How would you integrate that? There is a square. How would you integrate that? Notice that the derivative of x squared plus 1 is what? 2x. So here you have to do a u substitution where u is x squared plus 1, and it will work out. Okay, I'm not going to show you the details. And then how about the middle one? The middle one is the one which is a bit more work. You have to rewrite this as -x over x squared plus 1, and then -1 over x squared plus 1 dx. Yeah. And then of course this -1, instead of writing that -1 here, so this negative can be taken outside, right? And that will be just what? 1 over x squared plus 1. And that's the derivative of what? The inverse tangent. So this would be negative inverse tangent. How about this guy? Yeah, but what do you have to do to find the integral? You take u to be x squared plus 1 again. Yeah. So you have to do 2 u substitutions and then tangent inverse there, okay? I guess what you're going to get this one to be is that this one will become, at the end, I think, negative half ln of x squared plus 1. Okay? And I'll let you figure out what this guy is, okay? What you're going to get is 1 over, you're going to get half of integral of 1 over u squared. And then integral of 1 over u squared would be u to the negative 2, so it's negative 1 over u. Okay, so that will be half 1 over u. And so this would be, I think, this would be half 1 over x squared plus 1. Okay, and so you can plug those in. Everybody's okay? I'm going to end here because we are out of time. Any questions? Anyone? Okay, your first problem. He has some. What did I do with the homework? You have the homework 7.3 with you?
I do.
No,
No, I haven't.
What are you doing? Depends. Which one are you looking for?
Okay, so here's the problem. Wow, you fools. Here's the problem. X squared minus 9 over x cubed dx.